If you've taken Algebra 2 before, you can understand the solution to this problem. Feel free to give it a shot and keep watching to see the solution. Okay, so this is a system of equations, and why is it a system? Because we've got 3 equations and 3 unknowns, a, b, and c. And they tell us that a, b, c have to be integers, and we want to find ab plus bc plus ca. Okay, so we're familiar with solving systems of equations with 3 variables. This is familiar territory. We're familiar with when the left-hand side is linear, but what's different here? The left-hand side is what? It's nonlinear. So when facing a problem that looks unfamiliar, try to convert it into one that looks familiar. So how do we do that? Well, with systems of equations, how do we solve them? How do we solve systems of equations in Algebra 2? So there's substitution, and there's also elimination. Which one should we try here? Well, we could try both. If one doesn't work, we could try the other approach. And sometimes you have to do that with these kinds of problems. So yeah, let's give substitution a go. So substitution involves getting a variable by itself. So we could do c equals 100 minus ab. So get one variable by itself and then try substituting this. So try substituting this into another equation. So what that means is I would change c here to this. So the second equation becomes what? It would become b times 100 minus ab plus a is equal to 87. Now, did doing this help us? Do you feel like doing this helped us get closer to the solution, or it put us farther away from it? Well, this looks a lot messier compared to the equations that we were initially given. Like, we could try expanding out here, but yeah, if we try expanding out here, it'd be like 100b minus ab squared plus a equals 87. And now this is even more complicated than like this, because the degree here is higher. So maybe we should explore elimination then. So what would elimination look like? Remember, our goal here is to get linear factors, or to get linear terms at least on the left-hand side of the equation. It doesn't have to look like this, but we want to get rid of the nonlinear. Non-linear. Yeah, we just don't want the left-hand side to be nonlinear. Okay, so elimination. So elimination is when you add the equations together, or when you subtract the equations together, or add multiples of a certain equation to multiples of another equation. But I think for this problem here, we can directly add the first 2 equations, or we can directly subtract them. How come? Well, let me copy it real quick here. Okay, bc plus a equals 87. Yeah, so you'll notice that we have ac here and ac here. So that means if we add them, then the resulting equation would be factorable. Also, if we subtract them, the resulting equation would be also factorable. So, and when we factor it, we're going to end up with 2 linear terms, which is exactly what we're looking for. We want linear terms. Okay, so should we add or subtract then? Well, I think we should subtract. How come? I'll subtract first and then explain why. So this equation minus this equation. So it's going to be b times a minus c plus c minus a is equal to 13. And then I can rewrite this as minus 1 times a minus c equals 13. And then this is b minus 1 times a minus c is equal to 13. Yeah, so we have two linear factors now. Two linear terms. We got rid of the nonlinear term. So this looks better. I think it looks better. Okay. And they tell us that a, b, and c have to be integers. So what does that say about this and this? They also have to be integers. Now, if we added the two equations instead of subtracted the two equations, we'd still end up with two linear terms, but the right-hand side would be much bigger. It would be 187. And we want smaller because in this case, there are only 4 possible values for this. If this was 187, then there'd be more possible. Okay, I'll just add them. I'll add them and just demonstrate why. Okay, so if we add these two equations, what's going to happen? So it's going to be b times a plus c plus 1 times a plus c equals 187. So b plus 1 times a plus c is equal to 187. Okay, so now, right, 187 has a lot more divisors. It has a lot more divisors than 13. So this can be a lot more, this can take on a lot more values. Like this could be 1, it could be 11, it could be 17. These are all divisors of 187. It could be 187. This could also be -1, -11, -17, -187. Yeah, but here, what's this allowed to be? Remember, 13 is prime. So this can only be what? This can only be -13, -1, 1, and 13. Right? 4 is a lot less than 8. 4 cases to check for B. Okay, so let me get another sheet of paper. Okay, so if so b minus 1 can be equal to -13, -1, 1, or 13. So b can only be equal to what? Well, we just add 1 to all of these here. So it would be -12, 0, 2, and 14. So can b be equal to, let's check if b can be equal to 0. We'll plug b equals 0 back into the system. And the reason why I'm checking 0 first is because 0 is the simplest number to check. It's the easiest number to check, right? Because there's multiplication in our system, and when you multiply it by 0, then well, it becomes 0. Okay, so let's go ahead and plug in b equals 0 into the first equation. I'll write it here. Okay, so if b equals 0, then that means from the first equation we get c is equal to how much? Let me get another pen. That means c is going to be equal to 100. Okay, then what? Then that also means a is going to be 87 from the second equation. Now, is the third equation going to be true? Well, c times a is going to be 8700 plus b, which is 0. Is this equal to 60? No. So that means 0 doesn't work. Let's try the next simplest possible value for b. So if we do that, and we go back to the first equation, what does it turn into? It's going to turn into 2a plus c is equal to 100. And how about the second equation? The second equation is going to turn into 2c plus a is equal to 87. So if I add these two equations, I get 3 times a plus c is equal to 187. Since this has to be an integer, the right-hand side also has to be an integer if I divide both sides by 3. And 187 is not divisible by 3. So this is supposed to be an integer, but this is not an integer, so we're at a contradiction here. So B can't be 2 either. Now let's try 14. We'll try this one last because I don't like working with negatives. Okay, so the first equation turns into 14a plus c is equal to 100. How about the second equation? 14c plus a is equal to 87. And then add both equations to get 15 times a plus c is equal to 187. All right, and then a plus c is how much? A plus c has to be an integer, but it's also equal to 187 over 15, which is not an integer. Contradiction. So we arrived at a contradiction, so that means b is forced to be negative 12. Okay, so if b is negative 12, let's go ahead and plug that back in. Okay, so negative 12a plus c is equal to 100. Negative 12c plus a is equal to 87. So that means if I add both equations, I get negative 11 times a plus c is equal to 187. So a plus c is equal to negative 17. Okay, and now I can get a by itself or c by itself and go back to one of these equations and plug it back in. Okay, so let's see here. Let's just say that negative 12, okay, so a would be negative c minus 17. Negative c minus 17 plus c is equal to 100. Okay, and all right, so that means 12c plus, let's see here, plus, what's 12 times 17? 84, 12, 204, 204 plus c is equal to 100. 13c is equal to negative 104, c is equal to negative 8. If c is negative 8, then a is how much? A has to be negative 9. And then that means b has to be how much? Well, oh, we plugged in b is equal to negative 12. Yeah, b is equal to negative 12. All right. So to answer the question, they want us to find AB plus BC plus CA. So what's that going to be? Okay, I'll copy it here. I'll copy what we have for A, B, and C onto here. So A is equal to negative 9, B is equal to negative 12, and C is equal to negative 8. So AB plus BC plus CA is going to be equal to how much? Okay, so A times B, that's 108, plus B times C, 96, plus C times A, 72. 108 plus 72 is 180. 180 plus 96 is equal to 276. This is your answer.